Hello everyone. Again, this is your junior high school math teacher, and the next video that I'm going to discuss is about triangle similarity theorems, and this is under week 7 lesson 1 of mathematics 9. Now, from the objectives, of course, after you watch the video, you should be able to illustrate the conditions for triangle similarity theorem, prove the condition for the similarity of triangles. So this is just a continuation of our discussion about similar triangles. And this time, aside from other than the definition of similar triangles, we will now consider the following set of statements which are known as uh, theorems, which can be used, or theorems that can be used to prove the similarity of triangles. And let us start with this next presentation or slide. Now, one way of proving the similarity of the triangles is using this first statement. We call this the triple asimilarity postulate. And another statement that can be used to prove the similarity of triangles is the double asimilarity theorem. Next is the triple S similarity theorem. And probably this is the last one, the SAS similarity theorem. Now let us consider each of the following. So let us go back to the triple asimilarity postulate. Now this postulate states that if the corresponding angles of two triangles are congruent, then the triangles are similar. Moreover, if in two triangles where only two corresponding angles are congruent, it follows that the third pair of angles are also congruent by triangle angle sum theorem. Okay, next, we have the double asimilarity theorem, which states that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Third statement, we have the triple asimilarity theorem, which states that if the corresponding sides of two triangles are proportional, then the triangles are similar. So if we go back to our previous topic, from the definition of similar triangles, there are two conditions. So two triangles are similar if their corresponding angles are congruent, and then their corresponding sides are proportional. So in this particular theorem, the triple asimilarity, now this statement states that if the corresponding sides of two triangles are proportional, then the triangles are similar. So here you will notice that uh, the statement did not mention about the congruence of their corresponding angles. It means if we declare that the corresponding sides are proportional without even declaring that their corresponding angles are congruent, this statement, the triple S statement, is enough to declare that the two triangles are similar. Okay? Likewise, when we go back to the triple asimilarity postulate, this statement did not include the proportionality of the corresponding sides. It means if we declare the corresponding congruent angles of two triangles, this condition would be enough or is enough to conclude that the two triangles are similar. Okay? So if you don't have any questions so far with the first three statements, let us consider the last one, the SAS similarity theorem. Now, given two triangles, if two sides of one triangle are proportional to the corresponding sides of the other triangle and their corresponding included angles are congruent, then the triangles are similar. Okay, now for you to fully understand each of these four statements, let us go back to the first one, the triple asimilarity postulate. So again, let us read the statement. If the corresponding angles of two triangles are congruent, then the triangles are similar. Okay? Now, suppose we consider a drawing to illustrate the triple asimilarity postulate. Let us assume that the first triangle that you see right now is named as triangle BIO. So this is point B, point I, and point O. And this triangle is similar to another triangle whose name is triangle MAN. So obviously the smaller triangle is named as triangle MAN. Now, how do we know if these two triangles are similar? One way of doing that is we try to pair the the vertices from these two triangles, and the best way to do that is to place the smaller triangle to the inside the bigger one. Yun. So the bigger triangle is named as triangle BIO, and the smaller one is named as triangle MAN. Now, by triple asimilarity postulate, therefore, we could say that, okay, angle B is congruent to angle M. Likewise, angle I is congruent to what? Angle A. And finally, angle O is congruent to its corresponding angle N. Okay? So again, with this particular postulate, uh, the statement did not mention about the proportionality of the corresponding side. So it means this condition is enough to prove that the two triangles involved here are similar. Okay? Next. We go to the triple asimilarity theorem. Again, we read the statement. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So again, we refer to the same pair of triangles, and as usual, we assume that triangle BIO is similar to triangle MAN. Now, how do we prove their similarity based on the double asimilarity theorem? It means we need to just declare two pairs of corresponding angles, or two corresponding angles. So that the first corresponding angles are what? Angle B together with angle M. So these are the corresponding angles, and obviously they are congruent, and that is your first A from the two. So we need another A, or another pair of corresponding angles, and that is angle I corresponds or is congruent to angle A. And this will serve as your second A. Therefore, at this point, we have already established the triple asimilarity theorem. And with these two pairs of congruent angles, this would be enough to declare that the two triangles are similar. Triangle BIO is indeed similar to triangle MAN. Okay, next. For the third theorem or statement, we have the triple asimilarity theorem. And this theorem states that if corresponding sides of two triangles are proportional, then these triangles are similar. So mathematically speaking, we declare the proportionality of the corresponding sides of the two triangles involved. Again, we use the same pair of triangles. Triangle BIO is again similar to triangle MAN. So, How do we know if these two triangles are similar? So by this theorem, we are going to establish the proportionality of the corresponding sides from these two triangles that are similar. So how do we form the proportionality of the corresponding sides? Ito yun. BI, which corresponds to MA, so we form the ratio. BI over MA is equal to another pair of corresponding sides, and that is IO over AN, which is also equal to the ratio of another pair of corresponding sides, segment BO over segment MN. Ayan. Okay? And at this point, we have just established the similarity of two triangles because of the proportionality of their corresponding sides, which is this one. Okay? And again, we call it the SSS similarity theorem. Next. Okay. We're not done yet. Now, suppose the smaller triangle has the following lengths from its three sides. Okay? So, MA is 6, AN is 8, and MN is 10. And that is from the smaller triangle MAN. Now, for the bigger triangle, all its sides are also given. The length of all its sides are also given. So, BI is 9, IO is 12, and BO is 15. Now, if we substitute the given lengths to the proportion, you will notice that 9 over 6 is equivalent to 8 over 12, which is also equivalent to 15 over 10. So, any of these three values represent the same, any of these ratios represents the same uh, value. And what is that value if we're going to reduce each of these three ratios to its simplest form? It's actually 3 over 2, or we call it 3 is to 2. And we know that is what? The scale factor, or the ratio of similitude. Meaning, for every 3 units on the bigger triangle, there is a corresponding 2 units on the smaller triangle. Okay? Next. Okay, let us go to the next slide. Particularly the SAS similarity theorem. Given the two triangles, okay, I spoke too soon. We have not finished discussing all those statements of related to similarity of triangles. Okay, so we have the SAS similarity theorem. Given the two triangles, if two sides of one triangle are proportional to the corresponding sides of the other triangle, and their corresponding included angles are congruent, then the triangles involved are similar. Okay. Now, suppose we have two triangles. Okay. The first triangle is named as triangle ABC, and the other triangle is triangle DEF. Okay. So as you can see, I put identical slash marks on those segments, meaning that segment BM is congruent to segment ED. Okay? Likewise, segment MN is congruent to segment DF, and segment BN is congruent to segment EF. Okay. Now, angle A is congruent to angle D. So these are the corresponding angles from these two triangles. Next. And AB over DE, so these are the two corresponding sides, is equal to what? AC over DF. Okay? Now, with these two statements, they form, mathematically, they form the SAS similarity theorem. So it means these are the corresponding two sides of from the two triangles, and angle A together with angle D from the two triangles are the corresponding included angles. Okay? And with that, we have just established mathematically the SAS similarity theorem. Okay? Yeah. Now, suppose angle A is 40, obviously angle D, the corresponding angle to angle A is also 40 degrees. Next, AB is 9, meaning the 9 here is actually the length of segment AB from point A to point B. And AB corresponds to segment DE, whose length is 6. So we can uh, establish the ratio of the corresponding sides, and that is 9 over 6, which is equal to what? 12 from segment AC over 8 from segment DF, because these two segments are correspondent to one another. So it means 9 over 6 is equal to 12 over 8. If we're going to simplify both to their simplest form, we obtain the same ratio, and that is what? 3 is to 2. And 3 is to 2 is what? The scale factor or the ratio of similarity of these two triangles. Okay? Yeah. And with these conditions, we can now therefore conclude that triangle ABC is similar to triangle DEF. Okay? Next, we go to the next slide for some examples or illustrative examples. Let us take the first one. Find the missing lengths if the triangles are similar. So we need two triangles. The orange one, which is actually the bigger triangle, and this one right here, whose color is probably white or somewhat light blue. Okay? Now, these two triangles are assumed to be similar to one another. And from the bigger triangle, the two sides have given lengths. The longer one is 42, and the horizontal side is 33. Likewise, from the smaller triangle, 28, which is an obvious side correspondent to 42 unit side. Okay? And the other pair of corresponding sides are the one whose length is 33, and from the smaller triangle, the one which is labeled as x, since this length is unknown. So again, if the two triangles are similar, we know that the corresponding sides are what? Proportional. So at this point, we now form the proportionality of those corresponding sides. So therefore, we can set up this equation or proportion as what? 42 over 28. Okay, you form the ratio of the corresponding sides and equate it to the ratio of another pair of corresponding sides, which is 33 over x. Okay? And with this formed equation, we can now solve for x. And that is, okay, we do the cross product method. So 42 times x. So ito yon. And then equate that to the other cross product, which is 33 times 28. Okay? So we just put them together without performing operations on the two. Now, next is to divide both sides by 42, like this. And from From that point, the resulting equation would be what? Ayun. Okay, so what we did right here is we cancel the greatest common factor of 28 and 42, and that is 14. So that's the reason from 28, it becomes 2, and from 42, it becomes 3. Then we can still do some cancellation because 33 and 3 have common factor, and obviously that is equal to 3. So from 33, it becomes 11. Then from 3, this becomes 1. So anong ibig sabihin nun? We can now easily compute for the value of x, and that is 2 times 11. Those numbers uh, that are greater than 1, we can get their product. So that is 22. Therefore, the value of x is 22. Okay? Okay? Next example, number 2. Find the missing lengths if the triangles are similar. The same objective but different example. Now, what about this triangle? Now, you will notice we have smaller triangle which is coinciding the bigger triangle at this portion. So, we call this drawing as overlapping triangle because there is a smaller triangle which is placed on top of the bigger one. Okay? So, ano ibig sabihin nito? Now, suppose from this drawing, there are some lengths, some segments or sides with a given lengths. So, this segment is 12. Likewise, this is also 12. And this segment right here is 7. And this one right here is 14. And this entire side has a length of 22. Now, there is an x here which is labeled to this portion. So, ang tinatanong dyan, ano ang length nito? Represented by x. So, again, we apply the proportionality of the corresponding sides from those two triangles involved from this illustration or drawing. Alright. So, we have 12 over x. This one, 12 over x. Okay? Which is what? Equal to 12 plus 12 over 22. Okay? So this is how we establish the proportionality of the corresponding parts from the two uh, triangles that are assumed similar. Okay. So if this is now the formed proportion, we can easily get the value of x. Okay. So we know 12 plus 12 is 24. So kaya naging ganitong equation. Then you do the cross multiplication process. So 24 times x, this is the result. And then we equate that to another cross product. And that is 12 times 22. So equals 12 times 22. Then divide both sides by 24. Ayun. And from here, we can do some cancellations here. Ayun. Siyempre, yung left side magiging x na lang. How about 12 and 24? So, mayroong common factor yan. Obviously, it's 12. Because 12 divided by 12 is 1. 24 divided by 12 is 2. And we're not done yet with the cancellation. Because 22 together with 2, there is a common factor between the two. And what is that factor? It's 2. So, the 22, it becomes 11 because we drop 2 from 22. Ayun yun. We do the same thing from 2 here. So, 2 divided by 2, it becomes 1. So, at this point, it's very obvious we can now easily get or compute for the value of x. And the value of x is 11. Okay? And this is how we end the discussion, and we'll see you next time.